So back to the difference between exact and measured. Exact is when you count stuff, like when you say 6 bananas, 12 books, 3 balls. And along with that, also, when you define stuff, like when you say there is 1,000 meter in a kilometer, 1,000 meter equals 1 kilometer, that's an exact. That's not a measured quantity. I didn't need to measure the 1,000 meter to say how much it's equal to 1 kilometer. The 1 foot is 12 inch. The 1 inch is 2.54 centimeter. All these are not measured values, are exact values. So what's measured then? Measured values is when you require a measuring tool or a measuring device to record the number. Like when you fill up gas and you fill up 2.4 gallons, that's a measured value. There is a machine measured that for you already. When you grab a ruler and you figure out how long is your fingernail, that's obviously going to be recording a measured value. Your weight, you're measuring how much of certain mineral in a blood sample. That's a measured value, obviously. So that's the difference between exact and measured values. So it's very important to recognize that everything that is being defined, in terms of conversion factors, these are exact values. They are not measured values. And whatever you are able to count, that's also an exact quantity. Okay? So that's the difference between these two things. It talks about unit conversion. It talks about sig figs. Let me start with sig figs, because it's a very important subject to touch on. And I believe it's being talked about somewhere here. All right. So, yeah. So here's a number in front of me that is 11.275. The rules when it comes to counting how many sig figs we have. First of all, we're not going to be looking for sig figs in exact values. We're going to only be looking for sig figs in measured values. You're not going to be asking questions. Can you please mute yourself, everyone, please? And once the floor is open up for people to ask questions, you can unmute yourself. So the rules are highlighted, some of them here in slide number 29, chapter 2, where it says all non-zero digits are significant. So that's why you see here that the 11275, there are 5 digits, all of them are non-zero digits, so that's why there are 5 sig figs. The next rule, zeros between non-zero digits are significant. And you see here what we call trapped zeros. Trapped zeros are the zeros that appear between 2 non-zero digits. So these are considered sig figs. And that's why you see here, I have 1, 0, 2, 7, 5, 5 digits, 4 of them non-zero, and the 5th one is a 0 that is trapped, therefore it's counted as a sig fig. The next rule, zeros to the left of the non-zero digits are non-significant. We call these leading zeros. Leading zeros, the zeros that appear before the non-zero digit. So all of these zeros are not counted at all. How about this 0, the one that's marked as number 2? That's a trapped 0. And all trapped zeros are significant with no exceptions. So how many significant figures do we have in this number then? I have 1, 2, 3. The next rule, zeros to the right of non-zero digits in numbers that include decimal points are significant. We refer to those zeros as trailing zeros. Trailing zeros, the zeros that appear after the non-zero digits. So you got the leading zeros, the ones that appear before the non-zero digit, and you got the trailing zeros, the ones that appear after the non-zero digit. So the difference between them, one are counted and one are not. But the ones that are not counted usually are the leading zeros. They're never counted. But the trailing zeros, they are only counted when there is a decimal point in the number. So because there is a decimal point right here, these two zeros are significant. And therefore, how many significant figures do we have in this number? We have 5 significant figures. How many significant figures do we have in this number? We have 3 significant figures. What if this decimal point is not there? Let's say the number was, I don't know if there's a, oh, here is one. Here is one. So let's look at this number, 220 kilogram. What do we have? We have non-zero digit, and this zero, it's a trailing zero. Do I count it? I don't have a decimal point. So right away, I know that is not a significant figure. How many significant figures do we have in this number then? 2 significant figures. 2 significant figures. So it's important. As we said yesterday, when I write the number down, the last digit is usually the estimated digit. So it will be confusing for me if I put that 0 in writing the scientific notation. I have to keep the sig figs the same. Meaning, if I have 2 sig figs in my non-decimal number, in my decimal number, and when I write the scientific notation, it has to reflect the same number of sig figs. So if I have a 2 sig fig decimal number, I have to have 2 sig fig scientific notation number. So that's why the correct scientific notation for the 220 kilogram is the 2.2 times 10 to the second, is not 2.20. Because 2.20, I have 3 sig figs now in this number, which doesn't
put it up a little bit? We can't see that.
Doesn't it?
Oh, there you go.
Yeah, it's not in line. Oops, sorry. It's not in line with what. Let me make it. Oops. Yeah. So that's why the 3 sig figs here, they don't coincide with what we have here. These are 2 sig figs. These are 3 sig figs. So the correct scientific notation for the 220 kilogram is a 2.2 times 10 to the second. So these basically are the rules for sig figs. And it become important when you measure values, not when you do exact values. What is that supposed to mean? Let's just say I want to calculate how many pounds for this number of microgram. The final answer has to depend on the measured value sig figs, not the exact value that is between parentheses. Is 1 pound equals 453.6 gram? That's an exact value. That's not a measured value. The 1 gram equals 1,000,000 microgram. That's an exact value. That's not a measured value. So the message that we're trying to deliver out of this slide is every single time you do a problem-solving question, your final answer has to have a sig fig that depends on the measured values in the question, not the exact values. And we will get back to that when we do conversion, unit conversions. All right, rounding up. Let's do rounding up. It's a very, very simple rule. The rule is when you do round up, let's look at this. If I want to round this number to 3 sig figs, all right, what is my third sig fig in the 26.272? My third sig fig is the 2 after the decimal point. I want to round it to 3 sig fig. What's after the 2? A number that's 5 or higher. If it's a 5 or higher, it rounds up the 2 to 3. And that's what you see here. It's 26.3. What if it's exactly 5? And I want to have a 26.2529, want to round it up to 3 sig fig. Same story again. I go to my third sig fig, which is 2. I look what's after it. I have a 5. It allows me to round it up to the higher number, which is 3. Same thing here, 26.15. I want to round it to 3 sig fig. Here's a 1. There's a 5 after it. It gets rounded up to 26.2. What if, let's see. Yeah, what if I want to round this number to 3 sig fig? Let's see, what I have. I have 26.221. Here's the 2. I want to round it to 3 sig fig, so that's my third sig fig. What do I have after it? I have a 2. That's lower than 5. I knock off everything after the third sig fig without impacting the third sig fig. That's why this number becomes 26.2. So the rule, when I do round up, whatever that digit that I want to stop at, I need to look at the digit right after it. If it's a 5 or more, then the digit of interest need to be rounded up by 1. If that digit is followed by 4 or less, that digit of interest stays the same. So this setup has multiple values. Some of them are exact, some of them are measured. Where are the exact values and where are the measured values? The measured values obviously is the 6 feet. The measured value is also the 0.01 meter per second. So the speed is a measured, and the distance is also a measured value. Everything else that is 1 foot equal 12 inch, 1 inch equal 2.54 centimeter, 1 meter equal 100 centimeter, 1 minute equals 60 seconds. All of these are exact values, and they do not play a role in determining the sig figs of the final answer. That means I'm down to only 2 values that's going to determine how many sig figs I have in the final answer. Is it the 6 feet or is it the speed, 0.01 meter per second? When I do multiplication or division, and this is the rule, when I do multiplication or division, the final answer will always equal to the least number of sig figs of the ones that got multiplied or divided. Let me repeat. I am multiplying A by B by C. A is 2 sig fig, B 3 sig fig, C 4 sig fig. My final answer has to be 2 sig fig, because the rule when you multiply or divide, the final answer should always be equal to the least number of sig figs of the ones that you are multiplying or dividing. All right, back to this operation then. How many sig figs of this measured value? 2. How many sig figs of this measured value? 1. My final answer will be only 1. Let's take another example. Here's another one. I have a 5.2 liter of blood. The question is, what is it in quarts? Okay, I set it up. And again, I left out the unit conversion, how to set up the conversion, and I'm focusing only on the sig figs here. What is it? My final answer has to be based on the measured value that I started with. The only measured value here is 5.2, because the 1 gallon equals 3.785 liter is an exact, and 1 gallon equals 4 quarts. That's also an exact. That means my final answer has to be equal to the number of equal to the measured value that I started with. So I have a 2 sig fig. My final answer has to be also 2 sig fig. So let me recap in regard to multiplication and division of sig figs. Every single time I have an operation and I see an exact value within it, I ignore that when I count the number of sig figs of every single number I'm multiplying or dividing. Why is that? Because my final answer depends only on the measured values sig figs. What's the rule when I multiply or divide? Then the final answer has to equal the least number of sig figs of the ones that I'm multiplying or dividing. All right. The next operation, which is addition and subtraction. Addition and subtraction, the rule is a little different. And let's take an example. I have a 6.2 gram beaker with liquid, and I have, I'm trying to figure out how much liquid is in there. So let me get to this. So when I do the 6.2 minus 52.3812, When I do this on my calculator, I'm going to get an answer that is 7.8188 gram liquid. What is the correct number that I need to report though? Well, that will depend on the rule of adding subtraction of sig figs. What is the rule? The rule says the final answer in an operation of addition or subtraction of sig figs has to have the least number of decimal places among the ones that you are subtracting or adding. Once again, your final answer in the addition or subtraction of sig figs has to have the least number of decimal places among the ones that you are subtracting or dividing or adding. I have a 60.2. How many decimal places do I have? I have 1. What do I mean by a decimal place? Whatever after the decimal point. How many values I have after the decimal point? I have 1. 52.3812. How many decimal places do I have here? I have 1, 2, 3, 4. I have 4 decimal places here. So when I do subtraction, I have to decide, all right, my final answer is supposed to have 1 decimal place or 4 decimal place. It has to be 1 decimal place. All right. When do I input that 1 decimal place? I do that operation as is in my calculator, and I decide what is my 1 decimal place? Is the 8. What do I have after it? I have a 1. I knock off the 1, 8, 8, and I report 7.8. Unit conversion is basically when I give you a certain measurement in a certain unit, and I'm telling you, all right, get it to me in a different unit for the same measurement. Meaning, I give you ounce, I'm asking you for it to be in grams. I give you pounds, and I'm asking you to be in kilogram. I'm giving you a kilometer, and I'm asking to be in miles. I'm giving it to you in Celsius, and I want it to be in Kelvin. That's a unit conversion. Sometimes they refer to it as dimensional analysis. Dimensional analysis is the same thing. All right. The whole subject depends on something we call it conversion factors. Conversion factors. Let me see. Yeah, this is the word, conversion factors. What's a conversion factor? Conversion factor is when you set up an exact value, saying 1 ml equals 10 to the negative 3rd liter. Or I can also say it, which is easier actually for all of us, 1,000 ml. 1,000 milliliter equals 1 liter. That's a conversion factor right there. But it comes from an exact value. How do I write this down? I write this statement in a conversion factor. This is what we call a conversion factor. Conversion factor is just a rewritten statement telling me what the exact value is. When I say 1,000 ml equal 1 liter, this is written in a non-conversion factor format. If I want to write it in a conversion factor format, I have to write it as 1,000 ml over 1 liter, or 1 liter over 1,000 ml, or I can write this exact conversion factor as 1 ml equals 10 to the negative 3rd liter. I just brought this down, 10 to the negative 3rd. It's totally up to you how you want to write it. I usually prefer the top version just because it's easier to say there is 1,000 ml in a liter rather than saying there is a 10 to the negative 3rd liter in a ml. That's not that easy to say anyways. So that's why I keep telling everyone that try to stick it to the easier version to say it, which is the smaller quantity equals 1 whole larger quantity. So somebody might say, all right, I understand that you just said that this exact value, it's a statement, and I'm going to write it in a conversion factor. Why do we write it in a conversion factor in the first place? Conversion factor is something we use in our unit conversions setup. It's not logical to use this as part of an operation to convert one unit to another. We use what we call conversion factors. Somebody might say, all right, I see the 2 conversion factors written right here. They're almost the same, but they're not written, they are flipped. One says 1,000 mil equals 1 liter, and one says 1 liter equals 1,000. Which one is more correct? This will depend on what you are being asked about. So the question will determine which way am I supposed to set it up. So let's take an example. Let's take an example. If I have, let's see, is it a, I think, okay, well, let's talk about this question. Asking you to go from kilogram to gram. Let me just, I'll see where the question was. It's supposed to be written somewhere. Okay, let's deal with questions that have multiple conversions next. Let's deal with questions that deal with hopefully simpler conversions, and we'll go back to that one. Here's a question. Let's convert 254 meter to feet. All right. So basically, he's giving you meters, and the unit that he's asking you for to get it to is in feet. All right. What's the conversion factor between meter and feet? Well, you're going to learn that actually the from the exam handout and from your textbook, you could find this as well, that the 2.54 centimeter equal 1 inch, and the 1 feet equal 12 inch. So basically, the connecting point between the feet and meter is the inch. The 1 foot equal 12 inch, and 1 inch equal 2.54 centimeter. And I know already that there is a conversion factor between centimeter and meter. So now I'm dealing with basically a puzzle that I need to set it up correctly. In order for me to go from meter to feet, I have to go from meter to centimeter, and from centimeter to inch, and from inch to feet. So starting with what's given to me in the question, which is 254 meter, I need to cancel out the meter. That means I have to think of a conversion factor that will cancel out the meter and will set up the appropriate unit that I should relate the meter to, which is centimeter. How come? Because the centimeter is the one that's going to take me to the inch right after. What's 1 meter equal to in centimeter? We already know that the 1 meter equals 100 centimeter. So the way this conversion factor was set up is for the purpose of canceling out what's given to me as a unit in the question, because that's not what the question is interested in. It's interested in getting the final answer in feet. So in order for me to cancel out this meter, I have to set up the conversion factor in a way to cancel out that. And that's why this conversion factor came up in the format it is in. All right. Now, what's next? What's next? I need to get the centimeter to inch. So I have to basically set it up in a way to cancel out the centimeter. And I already know that the conversion factor between inch and centimeter is 1 to 2.54. That's another exact value that's usually given to you in an exam handout. All right. Remember, he's asking to convert meter to feet. So I am basically one step away to get the inch now to feet. And that's where the final conversion factor comes in. The 12 inch to 1 feet is been set up in a way to cancel out the inch. And having the foot in the numerator, so that way my final answer ends up with the unit foot or feet. All right, back again. So the question, once again, was asking me to convert 254 meter to feet. That means I have to think stepwise how to convert meter to feet. Meter has to be taken to centimeter. Centimeter has to be taken to inch. Inch has to be taken to feet. Somebody might ask, okay, how do I know that this is how the sequence of the steps? Well, you're going to look at your exam handout, and you look at the conversion factors available to you, and you're going to see the starting point, and you're going to find out the final point. and you will need to find those conversion factors that link the final and the end point. The starting point was meter, the final point was feet. We will go and hunt for those conversion factors that basically link the two together, and that's the three that connect the two together. So meter times a conversion factor that need to be set up centimeter to meter, so the meter will cancel out. The next centimeter need to be canceled out with another centimeter, so that's why inch to centimeter has to be set up in this way. Inch has to be canceled out, that's why the foot to inch has to be set up this way. And this will allow me now to cancel out the meter with meter, centimeter to centimeter, inch with inch, and end up with final answer in foot. All right. I plug this on my calculator. What's my final answer? My final answer is a calculator answer that is 833. And the number of sig figs has to match the measured value in the question. It's not going to match this, not going to match this, not going to match the other. Why? Because these three are exact values, are not measured values. So besides the unit conversion, I need to pay attention to sig figs as well. Okay. Back to the question that we just skipped, which is asking us to convert, kilogram to milligram. So he's giving me 0.003617 kilogram, and he wants it to be in milligram. All right. What's the connection between kilogram and milligram? The basic unit. What's the basic unit? Gram. So now I know, in order for me to go from kilogram to milligram, I have to go from kilogram to gram, and then from gram to milligram. So the kilogram to gram, we know already that there is 1,000 gram in kilogram. This is something you have to remember, because all the metric prefixes that we referred to yesterday in chapter 1, something you have to be familiar with. Whether you want to memorize it, whether you want to keep practicing until you are familiar with it, figure out that. But conversion factors, unit to another unit, that is something I will give it to you. Like going from inch to feet, feet to centimeter, meter to mile, kilometer to feet, all that will be given to you. But when I'm talking about metric prefixes, deci, centi, milli, kilo, giga, mega, micro, these have to be memorized. All right. In order for me to cancel out the kilogram, I have to set up this conversion factor as the following: gram to kilogram. How many grams in a kilogram? 1,000 gram in a kilogram. All right. Now what? Now I need to get the gram to milligram. So now I know that there is a conversion factor I need to set up, which is gram to milligram. What is the conversion factor here? There is 1,000 milligram in a gram. So now I have the setup ready. Kilogram will cancel out with kilogram, gram will cancel out with the gram, and I'm going to end up having my final answer in milligram. I plug all this in my calculator, and my final answer is supposed to have the same number of sig figs of the measured value. Why is that? Because these are exact values. How many sig figs do we have here? We have 4. So I plug this in my calculator, and I will find that my final answer is 4 sig figs. So here is a 164 pounds being given to me. It sounds like measured value, obviously. And he wants it to take it to kilogram. All right. What's the connection between pounds and kilograms? Well, I will look at my exam handout, and I'm going to find that the kilogram to pounds is 2.2. That there is 2.2 pounds in a kilogram. All right. So I take the 164 pounds, and I multiply it by a conversion factor need to be set up in a way to cancel out the pounds. And that will only be when I put the kilogram over a pound. And the conversion factor, which is already stated for me right there, that the 1 kilogram equals 2.20. All right, 3 sig figs. My final answer should have 3 sig figs as well. Let's look at another one. Okay, let's see, what is this? This is talking about percentages. We haven't talked about percentages yet. Let me go back to yeah, these are just telling you to write a conversion factor, which is something I think it will be easier. Okay, decimal places and addition and subtraction. I mean, we could talk about these as well. I mean, this is addition, subtraction versus multiplication, division. We already know that the rule when you multiply or divide is that your final answer should have the least number of sig figs. So when I multiply 56.8 times 0.37, I know that I have 3 sig figs in one and I have 2 sig figs in the second. So my final answer should be 2 sig figs at the end. And that's why you see the final answer for A is a 2 sig fig, which is 21. Division and multiplication. Okay, I got 4 sig figs, I got 3 sig figs, I got 3 sig figs, and I got 3 sig figs. I do this in my calculator, and I keep in mind that my final answer should have 3 sig figs, and that's what I have, 5.88. Final one, division, 25.0 divided by 5.00, 3 sig figs divided by 3 sig figs. So I know my final answer should be 3 sig figs as well, and that's why you see 5.00. Subtraction, addition, the rule is different. It's not the least number of sig figs, it's the least number of decimal places. I have 2 decimal places, I have 3 decimal places, and I have 0 decimal places. My final answer should have no decimal places at all. No decimal places, because I have 2 versus 3 versus 0. The rule to have the least number of decimal places. So A, as you see here, no decimal places. It doesn't matter how many sig figs, it has to deal with decimal places when it comes to subtraction and addition. The second one, it's also a subtraction, 3 decimal places versus 2. My final answer should have 2 decimal places. So I do this in my calculator, and then I decide what is it that I need to plug in as my final answer. How to go from one unit to another, meaning if I'm giving you Celsius and I want it to be in Fahrenheit, if I'm giving you Fahrenheit and I want it to be in Celsius, if I have it in Celsius and I want it to be in Kelvin, if I have it in Kelvin and I need it to be in Celsius. So the good thing, converting one unit to another when it comes to temperature, I'm going to be giving you already the conversion factors, and let me just share with you what I mean by that. So this handout, which is the exam handout I was talking about this morning, you're going to see on top of the handout equations section. And in the equation sections, you will see the 1, 2 important equations for you to go from one unit to another. What is that supposed to mean? What it means, this equation is telling me that Kelvin equals Celsius plus 273.15. This equation tells me Fahrenheit equals Celsius times 1.8 plus 32. If I'm given Kelvin, I will basically just solve for Celsius. If I'm given Celsius, I will just add it to 273.15. If I'm given Celsius, I will solve for Fahrenheit by simply timing this by 1.8, then adding 32. What if I'm asking for Celsius? Sure, I'm giving you Fahrenheit. Then Fahrenheit minus 32 divided by 1.8. Whatever it is the case of that question that I'm going to be asking you to go from one unit to another in regard to temperature, just plug in what's known and solve for the missing variable. That's all. So you do not need to memorize any of these equations that have to do with temperature unit conversions. And once again, when it comes to temperature, keep in mind that there are 3 units, and there are, once again, Celsius, Fahrenheit, and Kelvin. And we already learned that
Celsius will be the one that's the standard international unit. It doesn't mean that the other two units are not appropriate, but if in terms of publication, in terms of some research to be presented, it would be preferred to be presented in the standard international unit, which is the Celsius. That's one thing. The second thing I want to talk about in this chapter, that is density. Density, it has to do, let's see what it is first. At the end, or is it at the back? I think it's maybe at the end. It should be somewhere here, where density has to do always with mass and volume of matter. This matter, when it has a density value, this density value, it's a constant value. What is that supposed to mean? What it means, if I have a water bottle that does have water, this water, regardless what its source, it will have a density value that is constant. This density may change if I change some of the conditions around it. For example, density of water, it will be different from density of ice, will be different from density of vapor, even though the three are the same matter. So changing the condition is the only factor that may change the density. Other than that, the matter itself will always be with a set value for its density. How do I calculate density? It's always going to be calculated by dividing mass over volume. The mass over volume. Mass has a unit that it's gram. Volume has a unit that is milliliter. Usually for gases, rather than solids and liquids, now somebody might say, okay, what do you mean by solids, liquids, and gases? Well, states of matter, state of any substance, this state can be solid state, liquid state, or gaseous state. Just like the example I just mentioned, water. Water could be in the liquid state, could be in the solid state when it's ice, could be in the gaseous state when it's vapor. When you boil something, obviously we'll notice that there are two states on top of each other. One is vapor, right on top of the liquid state. Only gaseous molecules, you will notice, and we're probably going to explain this even better in the next chapter, chapter 3, when we talk about gaseous substances, how they appear within them. Only gaseous molecules, you will see the density reported in gram per liter. Why? Because you're going to need a volume of 1 liter in order for you to get an unnegligible amount or a very useful number that easy to write, easy to read, easy to visualize. Otherwise, if I want to report it in gram per mil, it will be very, very small number. So that's the idea of why gaseous molecules density value has to be reported in gas per liter. So the take-home message out of this, density is always calculated by plugging the mass divided by volume, mass in grams, volume in milliliter. Unless we're dealing with a gaseous matter, then we're going to have to plug in the volume in liter in order for us to get a useful density value to be used. And I already mentioned this in my exam handout. There is already an equation. Let me just share. You could see it right there. The very first one, density equal mass over volume. Mass over volume.